Hiya, we're going to do a quick video on Arduino's switch case syntax, which is really powerful, but it's dead easy to do. So I've gone into Tinkercad, I've searched for Arduino, and I've grabbed the one that has the breadboard already wired up. It saves a bit of time. I've got 3 LEDs. I've connected them to pins 2, 3, and 4. I always avoid 1 and 0 because they're used for serial communications, and a lot of the times I've wondered why things don't work when I'm doing serial print. It's because these are used, so I never use them. So we'll click on the code. I've already turned it into text like the big boys and girls do, and you're given all of this nonsense, so I'll get rid of that. We're going to need pin mode, and we're going to need digital write, but I can just write that afterwards. So what switch case does, it looks at a variable or an integer, whatever you call it. It looks at the value, and depending on what the value is, it does different stuff. So it's really useful for when there's one value to look at, like one variable, and it has different values and you want different things to happen, which is a lot of the time when we're coding. So let's just jump in. So first thing to do is to declare our variables. So I'm going to say int white, that's my white LED, equals 2. And at the moment, the Arduino doesn't know that this is an input or output pin. It thinks it's an internal variable until we assign it in pin mode. And then I'm going to do int green is 3, and then int blue is 4. Don't forget your semicolons. And so that's it for the ins and outs, because all of these are just going to be outputs. So now we do in the void setup, let's do our pin mode. There's quicker ways to do this if you've got lots of pins to do with a for loop, and I'll show you that in another video. But pin mode, we can either refer to this as white or 2, and that is an output. And pin modes, don't forget the capital M, like I always do, and use the same case as you did. So if you've got capitals or a mixture of capitals and lowercase, it always has to be consistent. And that is an output. An output or input has to be in capitals as well. And then pin, capital M, ode, is also an output. So job done for our setting up our circuit. So if you want to know how something works, you just go to the Arduino website. I Googled Arduino switch case. I only came across this when I was buying a switch case for my son's Nintendo, but it's a really good piece of code. So what does it say here? Depending on what a variable's value is, we're going to switch to different parts of the code. And once it's done what we tell it to do, we break out of each part of the code. Now, it might sound complicated, but it really, really isn't. So at this point, you'll be thinking, what exactly are we looking at to switch between different parts of our code? Well, you're right, there's nothing to look at because nothing's going to change in this circuit. But what we can do is add a variable and make that variable change. And depending on the value of that variable, it'll say light up the blue LED or light up the green or light up the white one, or it could be anything. Controlling motors, LED displays, it could be anything you can put in these different parts of code. So I'm going to add a variable. I'm going to call it count. I'm going to initialize it to 0. It's always good to give variables a value, although I believe they do default to 0 anyway, but it's good to tell it to do so. So the code is, we're going to switch you're probably better off doing switch, because switch case doesn't work. We're going to switch between different parts of this code in the void loop, depending on what the value of count is. So switch to different parts of the code, depending on what count is. And this is a bit of an unusual sort of syntax, but we do have a Mario mustache to open it up. And then don't forget to put the Luigi mustache at the end, as if it's an if statement or whatever. I always put down here, end of void loop, and I tell myself end of void setup. So whenever I do ifs or anything, I always put some comments to tell me where they end, and then it's really loads easier to get to debug things that are not working. And nothing works first time. Trust me, I was a senior design engineer for years, and you always make mistakes, so don't worry about it. So here's our switch between parts of the code, depending on what count is. At the moment, count is 0 when we turn the Arduino on. And then inside, we tell it to do things like in this case, or in that case, do that. In this case, do this. And then in the other case, do the other. So that's the sort of way it's set out. So in the case where count is equal to 0, then we do a colon, a full colon, and then do stuff. After we've done that stuff, we break out of that part of the switch case, and then it breaks out and goes back to the void loop, or what the start of the program, and then it looks at what count is again. If count hasn't changed, it'll do the same thing. But it'd be pretty boring if we just only had one case when count was 0. So what we want to do is to be able to change the value of count internally without any switches or anything. And we can do that. So let's say to start with, we want to turn on the blue LED. In the case that count variable is 0, turn on the blue LED. So digital right, don't forget your capital W, blue, and you can either write high or you can write 1, logic 1. It's interchangeable. Now, usually when we turn something on, we want to turn it off afterwards. So just for now, we'll have a little delay, and I'm going to do delay, 500 milliseconds or half a second. And if I run this, let's look what happens. Here we are. So because count was assigned to 0 and nothing is changing it, we're looking at the value of count. And because it's 0, in that case, in the case that it is 0, turn on the blue LED. Now that's fine, but there's loads more we can do with it. In the case that the count variable is 1, and then we've got a normal colon, and then let's have another one in the case that count is 2, proper colon, and then for the first one we need to do some stuff, then break out, and for the second one we need to do some stuff and then break out as well. So what should we do? Well, let's copy this. If you're ever going to copy any code, make sure it's written properly, otherwise you're going to multiply all your errors. So I'm just going to paste that for the case that count is 1, and then paste that for when it's 2. But instead of turning blue on, and now because blue's already on to start with, I'm going to turn green on. And in the case 2, as in the case that count is worth 2, I'm going to turn on the white one. But you'll probably notice there's nothing changing the count variable at the moment. So guess what will happen? Only this will happen. So that was strange. Sometimes you get those little things popping up where there's nothing wrong with your code, but Tinkercad gives you some errors. So what I do, I usually copy the code in case it all messes up, and then just refresh F5. So I'll stop the simulation. Thanks Tinkercad for messing up my video, but it doesn't matter. We'll press start, and because case is 0, it's going to turn this LED on, wait a half a second, and then we're not telling it to do anything else. So we will turn it off again. Digital right blue 0, and then I'm just going to copy this for afterwards to when we really get into the case, the switch case. I'm going to digital right green low, and then digital right white low. But still nothing will happen because we're not changing the count variable. But I'll press start, goes on for half a second, and then turns off for half a second because case is 0. So it does this, breaks out, and then goes whee right back to the start again. And then count is still 0. But what we can do, we can change the value of count either inside one case or another, or we can increment the count here at the end of the switch case. And depending on where you do it, may have an effect on the code. But I'm going to try it here. So what I'm going to say, we can either say count equals count plus 1, and that's fine, or we can do count plus plus, which is the same thing. So basically what's going to happen, to start with case count is 0. So it's going to do this, it's going to jump out, and then it's going to increment the count. So now the count will be worth 1. The next time it goes through the switch, case 1 is true, so it's the green one that will turn on and off. Then it'll jump out and increment the counter to 2. So it's going to keep incrementing the count. But then, after it's done it, all 3 of them, count will then equal 3 or 4 or 5 or 6. So there's something we need to do. But let's start this at least and see how it works. And if you want to see what the value of count is, then what we can do is go back to the setup and do serial begin to set up the serial communication at a baud rate of 9,600 bits per second. And then inside, we can serial print the value of count. I usually do ln because it gives you a new line, and I'll put count, and then I don't need to do a delay because there's delays in the code already. So let's just open up the serial monitor and see what the value of count is when we're playing along. Thank you, Tinkercad. I don't like using the serial print command. Print does work better, to be fair. So now the code's working like it should now. Earlier it was resetting itself and going back to 012, which wouldn't happen. So Tinkercad's been a bit naughty, but I'll stop it, clear the serial monitor, and start again. So case count is 0, then it's incremented, and then it's incremented as fast as the pick can do it, which is way too fast. And this will go on until it overflows. And now it's not doing anything because the count value, it isn't 0, it isn't 1, and it isn't 2. Now, there's more than one way to fix this. And I think the best way to do it is to have another case, and there's a special one called defaults. And what that means is if the variable that you're looking at in the switch, as in count, If it's not either of the defined values, then you do something else. So what I'm going to do for the default case, as in when it goes above 2, I'm going to set it back to 0. Count equals 0. So let's see what happens now. If I clear the serial monitor, and remember, it's going to turn on the blue, then the green, then the white. And then it's going to increment the count to 1 more than this, which will be equal to 3. And that will get caught by this default and set it back to 0 again. So let's press play. And now you can see it's never going back to 0. And there's various ways to do this, but are nice because it sets the count to 0 and then it increments it. So it goes straight back to 1. So what you can do here, a little trick, you can say count is -1. And then it increments it, or you can change when you increment, but it really doesn't matter. So now I've got count goes to -1, it increments it to 0 and goes back through. So without any switches or anything, you've got complete control over these LEDs, but these could be anything. They could be motors, they could be whatever you want them to be. And also inside each case, as in inside case 0, you don't need to just be doing LEDs. You could be doing any sort of thing. Or by the way, it's usually nice to have a break within your default as well, just in case. So in summary, set your LEDs or motors or whatever they are, give them your pin modes. If you want to do a serial communication to look at values, then fine. And then we're going to switch to different bits of the code depending on whatever the value of this is. And this can be anything. And in here, we can do anything at all. We can do tones, it's limitless. So when count is 0, do that and break out. And then when count is 1, do that. When count is 2, do that. And you could have almost infinite, not actually infinite, or put it this way, you could have thousands and thousands of different cases if you want to. And then just make sure, like in this example, we increment the count, because otherwise it's only going to stay in the first case. And don't forget your default. So hopefully this was useful. And just so that you know, I've got a template for you. And here's the template that I made. It's I just called it Arduino Circuit Template Public. And that's with me on, well, nothing's coming up there, but it's Electronics for Engineers. Should be able to find it. Just delete what you don't need. All of these resistors are 220 ohms. I've got a 7-segment display. I've got dip switches. I've got a momentary and a latched switch. There's a few sort of instructions for you, but basically you can copy this and it can be one of your default templates that you can just duplicate in Tinkercad and make new stuff each time. So if I press this button switch, then it provides 5 volts to pin 12, which you can change the pin, of course. And if I slide the switch, then it's a latched action. And here we've got some 7-segment display resistors, and you can change this A, B, C, D segments, E, F, G. I haven't bothered with the decimal point because I never use it. So if we have all of them on, it's going to be 8. And if we turn off segment G, it's going to be 0, etc. So what you can do is, instead of dip switches, you can wire to where these wires are. So that's segment A, segment B, C, D, etc. If you are going to wire to the 7-segment display, make sure that you disconnect the segments from 5 volts, and now they're disconnected, so you can wire and put whatever signal you want. All right, so thanks for watching. Any comments, let me know, and I'm going to do loads more videos on cases and if for loops and whatever. Okay, so cheers.